In this video, we'll be upgrading the Taz 4 3D printer. It came out in 2014. It's starting to show its age. It's time to upgrade that gantry, add some nice linear rails, add some Slice Engineering and Bondtech parts, and restore its life. Stick around. Alright, so while I've got a few projects going on, I'm kind of in between the phases of those and upgrading some of the machinery in the shop, and part of that requires getting rid of old machinery. So I've got rid of and parted ways with my Shapeoko 3. I found a nice home for that. He's going to run with that and enjoy it, and I'm going to upgrade to the larger HDM when it's available. Should be a few more months. Unfortunately, that creates some downtime. During downtime, there's lots of things you can do. One of the things I need to do is retrofit this garage, clean it up and organize it a little bit better, to get an exhaust vent for my laser, to set up the area for the new CNC machine, and upgrade some of the other machines that I have. So when it comes to 3D printing fine details or small objects, I'll refer to the Flash Forge printers. You've seen the reviews on those. They work great. They have small nozzles. They're not the fastest, but the results that they produce are great. They're stable, solid gantries, and they move plastic around pretty well. But you know, I've had my Taz 4 since 2014. I bought it when it first came out. It was around $2,500. It was a pretty big investment, and I guess it speaks to the quality of the product, even though it's based on open hardware and rep standards, where most of the parts on the machine are 3D printed, which has worked out pretty well. But the open hardware has allowed me to adapt the design over the years. I broke compatibility with their release cycle probably a year after I purchased it, and that's the main reason that I did purchase it, so that I could change the extruder, change the firmware settings, add and do whatever I needed to do with it. So today's video is focused around that machine, and primarily because, you know, although it's worked well, it's been there's a lot of issues. It's 7 years old. For a machine to last that long in daily use is pretty incredible, but there is a lot of issues with the rigidity of the gantry and the print head and the weight of it all, and how in aggregate that just causes it to be challenging to get good results on it, reliable results and consistent results with first layer and all of that fun stuff. And so the thought is, you know, with the Flash Forge machines for my go-to on fine detailed small parts, is to why not make this Taz 4, upgrade it with some linear rails, make it more rigid, so that I can use it to build all of the parts that go inside of the products. So if you watch the video on the curve kit, there's lots of 3D printed parts in there. Most from the outside, and the finished product, you'd never know that they're in there, other than it causes the final product to be more rigid and have structure and have this sub-assembly that pulls it all together. And nobody cares what those look like, and so why put it on a Flash Forge and make it take 36 hours when you can put a 1mm nozzle on something like a rigid Taz 4 or an upgraded Taz 4 and create those strong, solid parts in a fraction of that time. So that's the idea. But to do that, I'm going to have to tear this thing down. Right now on the Taz, I've got the E3D hot end with an extruder that isn't the best. It's only got one hobbled nut, if you will, in a direct drive extruder, which causes it to strip out the filament often, especially if you try to push it, run it hard, bigger size nozzles. So that needs to be upgraded. And as part of the upgrade, we're going to go with a Bondtech extruder, the QR, which is the quick release system. It's got dual gears. It's going to be able to push that filament through there pretty quickly. Also, Slice Engineering has sponsored this video to provide a mosquito hot end. That's going to give us excellent flow, excellent heat profile and separation with the heat break to prevent from heat creep and all of those other issues that are generally an issue in the E3D hot end. So with the Bondtech extruder and the mosquito hot end, we'll be able to push lots of filament through there, running nozzles at 1mm plus. That'll make that machine you know, be able to flow the plastic, lay it down quick, and build quick internal parts that are strong and reliable with some consistency. But before I do that, I'm gonna have to upgrade the gantry on this machine to be more rigid, and that's gonna start with linear rails. So I'm gonna use the MGN 12 linear rails and rail blocks, and then we'll have to custom design some gantry pieces out of aluminum, mill those out, and put this thing together. But before we do any of that, I got to do a lot of design in Fusion 360. So let's hop over there and we'll walk through that gantry design. Okay, looking at the existing Taz design, we pulled it out on the table. You see it looks pretty solid. It's got this bed that moves back and forth, and they're on linear guides, 8mm linear guides. But there's a little bounce on the table. Carriage moves back and forth on 2 linear guides, and the carriage itself does have a lot of play in it. I think it has to do with the 3-point mount that they have, the way it's swappable. They've got this edge that seats down in, and then a top screw. Not the best, but it's a Titan Aero E3D V6. The frame of and construction of the printer in general is 2020 extrusion. It's pretty solid, but these have a lot of play, these linear guides, and with that carriage not being light, carrying around a stepper motor, it is pretty heavy. In general, the 2020 extrusion makes it a solid framework, but these linear guides continue to cause problems for reliability. You can see the little wiggle in the bed, the vertical, and granted, it's unlikely that will be exploited. When you try to push it to the limits by speeding it up and moving it around a lot quicker, that momentum causes problems with all of those little tolerances in play. Like I said, this is a Titan Aero E3D hot end. It's just got the one screw in the extruder which pulls the filament down in there. That always strips. This part I've modified to have a BL touch sort of embedded up into the hot end, so that bottom blower area is all custom designed by me. But it's very similar to the stock one, and this originally was just a stock hot end cartridge that was purchased, or extruder that was purchased. See those 2 heavy cords coming in there? It is set up for dual extrusion. That head only has 1 extruder on there. I don't really use dual on this particular machine. And you can also see that these linear rails were upgraded, or linear guides were upgraded to hardened steel, because you have the hardened steel bearings in there as well. So I don't have issues with tolerance between the bearings and the rails so much as I have with flex in those rails. Alright, now let's step over into Fusion 360. Alright, so nothing gets the creative juices going better like an empty project in Fusion 360. But before we get started on that new design, obviously I had to bring in lots of parts to support it. So any type of fan, like these 2510 fans that I used, the 2020 extrusion, limit switches, Bondtech QR extruder, the Slice Engineering Mosquito Magnum Plus hot end, all of those things were brought in either from GrabCAD, or Slice Engineering provided their model, Bondtech provided their 3D model, threaded brass inserts, existing Taz parts. Brought those all in so that I could simplify and work with those as part of the design. So stepping into it, obviously I first bring in the 2020 extrusion. We need that. That's what we're mounting the linear rails on. And these linear rails are the MGN12s, and the carriage block, of course. We duplicate that because we've got 2 of them. The reason why I use 2, you could probably get away with just 1, because this carriage is pretty heavy. It's dragging around a NEMA motor, a stepper with a gear reduction, and the hot end, and it's got a bit of weight. Plus, it's easier to adapt the printer, which is using those linear guides to just incorporate the extrusion and to make it linear rail system. So once those are in, I brought in the Taz End Plate. This is the motor mount end plate where the stepper motor mounts for the X-axis. I just had to modify this to accept the 2020 extrusion, then add a couple holes for these T-nuts to go in there, allow me to mount directly to the 2020 extrusion. These 3 holes on the end are threaded brass inserts, and this is how the side of the X-axis mount to the Z-axis plates. That's just part of the stock design. Next, I created a carriage plate. This is where the hot end is going to mount. This is going to be milled from aluminum. It's got some countersunk or for cap head screws, and then a couple screws in the middle for the mount, and you'll see later how the Bondtech extruder mount will leverage those. Bringing in the last piece of the assembly here, the idler, the X-axis idler. There's a couple bearings that go in here, and this is ultimately where the belt loops back, and it hinges on that. So I had to adjust this to obviously fit the 2020 extrusions as well, and then put the mount holes in place there. And then it brings us to the extruder. You see I've got the BL Touch also positioned where I plan to mount it. It's got to be within 3 millimeters of the tip of your extruder. This is two parts. So the top part, this is the Bondtech QR, which has the stepper motor with the gear reduction, 5-to-1 gear reduction into this Bondtech QR. This is just quick release. It's got a thumb screw that you can provide additional tension on the gears that are pulling your filament down into your hot end. And you can release it, open it up, clean it out. And the thing that's nice about this is gear reduction, so it's super strong, and it's got dual gear extruder in here. So the dual gears are pinching the filament that come down in through this cold end and then force it down into the hot end. From the fan, or this section down, is the Mosquito Magnum Plus, which has a 2510 fan here to cool the heat break. The heat break, which is unique to this design, is it's got these 4 standoffs, or these 4 poles, which isolate it from the hot end. And there's a cooling fins on this cold tube here to dissipate the heat. So this keeps all of the filament above this section cool so that the extruder can do its job, manipulate the filament and retract and extrude it, and then it isolates it from the hot heater block in the hot end from doing its job and keeping consistent temperature at the nozzle. And so the cool thing about the Mosquito Magnum Plus is that it's got this huge heater block. I mean, this thing's solid. It's also got room for 2 heating elements, so you can put 2 in there, as well as 2 thermistors. If you need that accuracy and redundancy, or you're really pushing a lot of plastic through there, then this is the block for you. Another neat aspect of the Mosquito Magnum Plus is their insulator. They don't use a silicone sock, they use this vanadium material, which is a hardened metallic type substance, which provides insulation to the nozzle by way of an air gap. It's around a millimeter air gap around the nozzle, so when you have your part cooling fan blowing on your nozzle, it's not going to steal the heat from the tip of your hot end. So, and this large heater block retains a lot of the heat, focuses it down there with a great heat break to prevent the heat from traveling up into the extruder. So that, in a nutshell, is the Bondtech QR connected to the Mosquito Magnum Plus. The Bondtech QR has its own mount, which is this cap, a pinned cap, which is 3D printed and registers in the stepper motor notchway. Alright, so moving forward, created this belt connector. It has 2 sides where the 2 ends of the belt will be attached that are looped back. We have some threaded brass inserts that are put in there. And then I beefed up this idler end to strengthen it, giving it more wall thickness to hold the linear rail and the extrusion in there. Next, it was time to, although the BL Touch is in place, it needed to have a bracket. You see I added some 3 millimeter threaded holes in the back plate to allow these sort of accessories to be mounted. After adjusting the BL Touch slope to be 3 millimeters above the nozzle tip, it was time to design the bracket for it, which would leverage these accessory mount holes on the carriage plate with an extrusion and a couple holes for nuts and adjustment hole, pilot hole. Then on the front we have another threaded brass insert, which allows me to create a part cooling fan. Using another 2510 fan, we create the bracket for that. Extrude it out. You can see the airway is going to be blowing a channel of air right there at the tip. Close it up and clean it up. With that complete, that's gonna provide the part cooling with enough clearance. And then on the back side we have the BL Touch, which is gonna be used for probing the bed. Alright, with the x-axis completed, it was time to move on to the y-axis. So I really just had to bring in the Taz part for the y-axis feet, which had this 8mm linear rail, which a lock nut on top, and just had to adjust it for the 2020 extrusion. There was already one 2020 extrusion in the feet there. I just had to add the second one where it needed to go. So adjusting that, chopping it up a little bit, and then placing the MGN 12 rail on there, created new feet, and then I just mirrored it over for the opposite side. So those MGN 12 rails would go right on top of the 2020 extrusion. We'd have the dual set of 2020s, and this would comprise the platform which the bed would ride on the linear guide blocks. All of these parts were taken over to the Flash Forge Adventurer 4 and 3D printed in ABS at a 0.2mm layer height. With all the parts at hand, it was time for assembly. Alright, to mill the carriage plate, first we took the material over to the CNC and just did a couple 2D operations, countersinking those cap head screw holes for the 3M carriage blocks. Then doing a profile cut. Next milled the pilot holes for the accessory mounts, and then chamfered everything. With that, we were done and ready for assembly. Alright, so here we have the linear rails laid out on the 2020 extrusions with the guide blocks on them. Kind of checking, you can hear the sound of those. They're pretty loud because of all the bearings they have in there. And then for the x-axis, we just have the two guide blocks on there. Those linear rails will need to be mounted. Here's the Bondtech mount, the y-axis feet, some plates that go on the y-axis, the idler end and the motor mount. And then these are all adapters for the fans, belt strap, the BL Touch mount, and then the carriage plate, which was CNC milled, which turned out great. All those 3mm threaded and countersunk cap head screw mounts. These will ride right on the linear rails as such, for nice, clean, rigid, solid connection. Alright, with that, we're ready to start assembling this. Alright, so first thing I had to do is tear down the Taz. So, taking apart the X gantry, there's really just 3 screws on each side and disconnect the wires. Done. Next, had to clean up, organize all those screws, make sure I didn't lose them, take off the glass bed, take out the 16 M3s, take off the belt, and the y-axis fell down as well. Take off the front plate and the back plate, and then remove the feet along with the linear guides, and we're done. Next, I took the linear rails and had to put the T-nuts on the back of them. Every other hole was used there, and then I just slide it into the 2020 extrusion, and then I 3D printed a alignment tool that would align the rail, and I could tighten the screws and know that they were centered on the rail. Did that 4 more times to finish off the X and the Y rails, and then we were almost good to go. It took some time to put all those T-nuts on there and tighten them all down and make sure they were all square and centered, but pretty trivial in regards to skill sets. Next I assembled the X idler pulley, just a couple bearings and an M5, and then I assembled the X axis by inserting those rails in the pulley ends. And then it was just a matter of tightening the T-nuts to lock the ends in place. With that, finished up the other side, and it was time to mount the carriage plate, which was just the 8 M3 screws. Test it out, moves back and forth, everything's square, we're good to go. Take that over to the machine, and like I said, just 3 M5s on each side, and we're done. Then it's just a matter of wiring up the wires, torquing everything down, and it looks clean and ready to finish it up. Moves back and forth pretty easily. Next were the Y-axis rails, and those had an adapter plates because I wanted to use the existing holes on the bed. And so I had the 4 or the 16 holes that went into the rail guides, and then there was the threaded brass inserts that would adapt it for the bed mount points. Those just went into place using the Y-axis feet that were modified in Fusion 360. Let's flip it around, do the same thing on the other side. Connect both of the 2020 extrusions to the feet, and then put the end plates on. And then you're good to go. Adjusting those tensions, putting the bed in place, tightening those 16 screws to mount the bed down. This thing is starting to feel rock solid as I was assembling it. Like there's no play or tolerance, which is great. I mean, you could almost make it a CNC at this point. Just need something more rigid for the Z gantry. Next, it was time to put some belts on this thing. I purchased some fiberglass reinforced belt, I think 6mm, and upgraded those just to give it a fresh start. If those other belts were 7 years old, they're probably stretched out, and they weren't reinforced. So stretching the belts, getting to the right tension, tighten them up with some M3 nuts, prepared that X-axis, and then routing some wires, a couple zip ties, and cleaning up the same thing for the Y-axis. Now I was starting to wire up the hot end and the extruder, and preparing that for the final installation. And this is what it looks like with the Bondtech and the Slice Labs Mosquito Magnum Plus hot end. Looks really clean, and it's a solid hot end. Before we get too far, electronic projects always start with good circuit designs, and for that I rely on Altium Designer. From simple to complex, if you haven't taken a chance to download a free copy and see what you're missing, I've put links in the description, and with Altium Designer, creating these complex projects is a piece of cake. Through your development, you'll be empowered to do your best work as you grow into its more advanced capabilities. The link in the description below will allow you a free trial version of the software so that you can check it out and see what enterprise class ECAD feels like. Now back to the overview. You can see the shroud there that with the air gap, about a 1mm air gap around the nozzle. Keeps it nice and hot and protected from part cooling fan. So I took that over with my wiring harness connector and started wiring up and soldering all my endpoints, using splicing them, as well as using heat shrink tubing and thermal insulation tubing that I put over all the wires that run down to the hot end. Just in case they happen to touch that inferno and burn up. I just wanted to protect them as much as possible because that's never fun. And this is the final assembly, ready to go, all wired up, zip tied and wire loomed. Just needs to be mounted to that carriage plate. Alright, so next, taking it over and mounting it. Take it over to the bed, first mount that BL touch to the bracket, and then mount that bracket to the carriage plate. It's in place. It's just difficult to get to those screws once the extruder's on, so I mounted it, squared it, got it the right height, and then mounted the extruder, just the 2 M5 bolts. And in that process, I just wanted to make sure that it was square to the bed, all the wires were in the right place, there wasn't anything getting pinched, and it was clean. You also see I got the drag chain that was installed on the top there. And although it doesn't look great, the wires in there are pretty heavy duty, and they wouldn't bend any tighter than that, so the drag chain is a little bigger than I would like it. Otherwise, the movement is just rock solid. There's like no play, no wiggle, no tolerance. Those linear rails did the trick. Now I probably need to do the same thing with the Z-axis at some point. But I think for now, X and Y is going to solve a majority of the issues that I was experiencing with this printer. So now it's rock solid. There's no way for the Y-axis or X-axis to wiggle or cause anomalies, and it should be a lot more consistent. I should be able to run it a lot faster, in fact. faster, as well as thicker layers with the new extruder and the Slice Engineering Mosquito Magnum plus Hotend. Should be able to really push them. I'm anxious to try out all these vanadium hot tips, but first I need to put it in there. And there it is. And it's heating up and extruding. Yes. So we were good to go. Next it was time to test this thing out. So we threw the test train at it at 200% scale, since this time we're going to do it with a 1mm nozzle and see how quickly we can get this thing knocked out. This will test the extrusion, and at a rate of 0.8mm layer height with a 1mm nozzle, it's going to be pushing a lot of filament. I don't expect this to look pretty. I expect it to be strong and have good layer adhesion. So we slice this thing up, and take a look at that. That thing is chunky. Alright, send it over to the printer and see what happens. Hit run on Octoprint, and this thing started printing out pretty quick. First try, my first layer was good. Never seen a 0.8mm layer height, so this was really chunky and coarse. So as it's printing it out, we'll save you some time and show you the finished product. Here it is completed, and you can already see the layer lines in there are super thick. Almost a millimeter in thickness. This thing was rock solid. Overall, I think this turned out excellent. It's the thickest layer I've ever been able to lay down. This took about an hour and 20 minutes, as opposed to doing it at a 0.2mm layer height, which would have taken probably 6 to 8 hours. So for those parts that are inside, internal components that need to be strong, don't need to look pretty, then this is certainly going to be a huge upgrade for my productivity. So here's a look at the final assembly. It looks clean. Those dual linear rails look slick. So if you have an old 3D printer you want to upgrade, then maybe this is a strategy that you can employ. Definitely go check out the link. Look at Slice Engineering's Hotends. They have some of the best Hotends in the industry right now. Bondtech has the best extruders, and there's plenty of combinations that'll work for anybody. If you want to support the channel, click on my affiliate link, make the purchase through them, and I will get some commission off of those sales. So that's going to do it for today. Hopefully you enjoyed this look at how you can take an old machine and upgrade it with the right parts to restore its life and bring it back up to date. Now this machine is going to serve its purpose in delivering high quality, high strength products. You know, obviously it's not going to be able to compete with the resin printers or the flash forged small nozzle tip printers, but it shouldn't. You know, every machine kind of serves its own purpose, and for the Taz, it's going to be the workhorse moving forward on these larger scale projects. Hopefully you enjoyed that look at adding the linear rails and improving the product design, which you know, maybe they'll incorporate into their final product one day. If you like this particular video, give it a thumbs up. If you're new to the channel, then ring that notification bell. It'll keep you informed on future updates. As always, be safe, have fun, and I'll see you next time. Hey, if you like the video, please subscribe to the channel. It's how we're building the community. Also allow me to bring better content. Also check me out on these other social networks. There's lots of cool stuff there too.